The entire figure is a 50 by 50 square with a right angle triangle at one corner having perpendicular sides 40-30, another right angle triangle that is partially overlapping at another corner, then another right angle triangle partially overlapping at the third corner, then another right angle triangle partially overlapping at the final corner, then a square is embedded within all of them. So because of a square has opposite sides parallel and equal, all sides equal, but opposite sides parallel and 90 degrees at every corner of it, it makes the opposite hypotenuses of the opposite right angle triangles parallel to themselves. So these two are parallel to themselves, these two are parallel to themselves, since they are part of the parallel sides of the square, of the small square. So since this one is part of this side of the square and this one is part of this side of the square and this side of the square are parallel, then these two hypotenuses are parallel. Same thing on this side. So we have parallel sides. So if these two are parallel, then the angle this one makes with this vertical side of this big square will be the same angle this one will make with the vertical side of this big square, since they are parallel. So the angle here will be the angle here. Then the same thing here, the angle it makes with the horizontal will be the angle this one will make with the horizontal. And same thing goes for this other set of parallel lines. The angle here with the horizontal will be the angle here with the horizontal. Then the angle here with the vertical will be the angle here with the vertical. Then something much more interesting is that because of this whole arrangement is such that the right angle triangles are embedded within a big square and having a smaller square having equal sides. So they are embedded within equal sides of this big square and having equal sides of this smaller square within them. It makes the relationship between them to not just be similar as we've explained, being parallel and having related angles. It goes beyond that. It means that they are all congruent, meaning that they are all equal to themselves. So all these right angle triangles are equal. So we have this angle here, which is this angle here, definitely the same with the angle here for this one. The angle this one makes with the vertical will definitely most likely be the same thing with the ones these other ones make with the horizontal, meaning that this one makes this with the vertical, then the one it makes with the vertical here should be the same too. Then the angle this one makes with the vertical, let me mark it with 2 arcs, is the same thing with the angle this one makes with the vertical here. Oh, let me go one by one. The angle this one makes with the horizontal will be the angle this parallel one to it makes with the horizontal, and the angle it makes with the vertical marked with 2 arcs will be the angle this one makes with the vertical. Then going to this other pair, the angle this one makes with the vertical should be the same with the angle this other one makes with the horizontal, meaning that the angle this other one makes with the vertical, which is this, oh sorry no, this, yes, which is this, should be the same with the angle this one makes. Yeah, so we've gotten it right now. Then makes this one to be marked double, just like this one too will be marked double. So getting all these angles and knowing that they are congruent, then you understand that the orientation here for all these right angle triangles is such that this one is a 90-degree rotation of this one, because this angle here is this angle here for this one. So just take your time and look at the diagram. When you rotate this one here, the angle marked 2 with 2 arcs is the angle you're seeing for this one here marked 2 arcs. While the angle marked 1 arc here is the angle you see here marked 1 arc. So it means that this one here is a 90-degree rotation of this one, and the next one is a 90-degree rotation of this one here, and the next one is a 90-degree rotation of this one here. So the orientation is such that each consecutive right angle triangle at every consecutive corner of this big square is a 90-degree rotation of the other one. So knowing that you have equal right angle triangles of 40, 30. So using this one as the one to draw this, you have something like this, right angle. So with the 90-degree rotation, it means that this side for this right angle triangle will be 40, while this side will be 30. Then this side will be 40, while this side will be 30 for this one. Then this side will be 40, while this side will be 30 for this one. So you have this. Then notice something else. The overlapping area for each of the right angle triangle overlapping with another one is also similar, because the angles you're seeing marked are similar in all of them, and by vertically opposite angles, the third angles of each of these small triangles, these overlapping areas, is 90 degrees. So because here is 90 degrees, then here will be 90 degrees by vertically opposite angles. Same thing here, same thing here, same thing here. So what it makes that be is that each of these small overlapping areas are also right angle triangles. You can see them looking like this. Using this one to draw. So you have this and this. Then now, if you look at this diagram, you know that this right angle triangle on this corner has its 40 here. So if this is 40 and you have 20 marked at this extent, it makes this remaining part of the 40 to be 40 minus 20, and that's this side of this one. That's 40 minus 20, which is 20. So you have 20 here, and this place is the hypotenuse of this small right angle triangle, because from a sketch we know that the hypotenuse is the longest side, but for a sketch where you can draw a shorter side longer than the longer side, so for a sketch it's best to take the hypotenuse as the opposite to the 90 degrees. So I know my sketch is not so fabulous, so it's best to understand that the hypotenuse is the opposite to the 90 degrees. So since the 90 degrees of this triangle is here, then the hypotenuse is opposite it. So this is the hypotenuse. So we know the hypotenuse of this, and we can get the hypotenuse of this with Pythagoras theorem. So we know that it will be square root of the sum of the squares of these two sides. That will be square root of 1600 plus 900. And that will be square root of 2500. And that will be 50. So we know that the hypotenuse of this big right angle triangle is 50, and the hypotenuse of this one is 20. Then the fabulous thing there is that this big right angle triangle, which is the same thing with every other big right angle triangle at each corner of this big square, is similar to the small overlapping areas which are right angle triangles, this, because of they have equal angles within them. The same angles, the same three angles we have in this big one are the same angles we have in this small one. So they might be of different sizes, but because of they have the same measure of angles in them, the three, then they are similar triangles. And by being similar triangles, the ratio of corresponding sides are equal. So the ratio of the hypotenuse of this one to the hypotenuse of this one will give you the ratio of this side to the corresponding side on this side. Will give you the ratio of this side to the corresponding side on this side. So since 40 is the opposite to the angle marked 1, then its corresponding side on this one will be this. Let's call it A, because that's the one opposite the angle marked by 1 arc. Then since 30 is the side opposite to the angle marked by 2 arcs, then let's call here B. It is corresponding to 30 on this one because of it is marked. It is opposite to the angle marked with 2 arcs. So when you find 40, or when you find when you do the ratio of the corresponding sides, that will be like 20 over 50, this hypotenuse over this hypotenuse. It will give you this side over this side, which is the same thing as this side over this side. So we can find what A and B will be. So finding A first, we know that A will be 20 times 40 over 50. That's 80 over 5, which is 16. Then B, 30 times 20 over 50, and that will be 60 over 5, and that's 12. To get the area of this square, which is the green square in the diagram, we would find the area of the whole big square and subtract from it the area of all the cyan region. And the cyan regions are made up of these right angle triangles and the partially obvious or the partially visible right angle triangles, all these other ones, because we know that some areas of them are hidden, are overlapping, so we are not going to call them full because it's just a part of them that will be needed. So we would have to figure out a way of finding the area of the cyan regions, then we'll subtract them from the area of the whole big square, then to give us the area of this green square left. So since we know that the hidden areas are this right angle triangle, and we know that there are 4 of them, then we can add up the complete big right angle triangle 4 times. Then for each of these extra ones we're adding, we'll remove these areas. So we're taking this big one as complete. Then when we add another one, which is this to it, we'll try to remove these 2. That's removing 2 of this small one. So when we now add this other one, we'll remove this part, since it is also having this part of it. So it's just this part that we don't need, so remove this part. That's 3. Then when we add this one, we'll remove this part, since this part of it is part. Because from the main diagram, you'll notice that this one doesn't have this part. It's just this part of it that is appearing. Then this one has this part and this part. It's just this part that is not appearing. Then this one has this part and this part, just this part that is not appearing. So when we add this to this one, we'll remove these 2 parts. That's 2 of this, Then when we add this one to them, we'll remove this part, which is 3 of this. Then when we add this part to them, we'll remove just this part, which is 4 of this. So 4 times the area of this, which is adding this 4 times, then minus these 4 areas of this that are overlapping and are not visible, will give us the entire area of the cyan region. So when we subtract that from the whole, that's the sum of that, then the difference between that's 4 of this minus 4 of this. When we subtract it from the total area of this big square, we'll just be getting this green square area left. So I hope you understand that. So area of 50 by 50 square will be 50 times 50, which is so obvious, which is so ordinary, because the area of a square is the square of its length. So 50 square, that's 50 times 50, that's 2500. Then the area of the, because we already have these areas now, so the area of the green square would now be equal to this area of this big square minus 4 times the area of all these big right angle triangles. And the area of these big right angle triangles will be half base times height. So the base and the height of the right angle triangle are simply just the perpendicular sides. So half times 40 times 30, then minus 4 times the area of this small one, as we've explained already. And the area of this small one, still half times the perpendicular sides, which are the base and the height. And they are 16 and 12. So we have 4 times 600 minus 4 times 96. That will be 25 minus 2400 plus minus minus will give us a plus. So that will give us 100 plus 384, and that will give us 484. So the area of the green square is 484.